So here's the problem. Parkinson's. For adults over the age of 60, 1 in 100 have it.
Parkinson's is a neurodegenerative disease that affects both motor and non-motor function. It happens when dopamine-producing neurons in a brain region called substantia nigra gradually die. And because dopamine helps control movement, this leads to symptoms like tremor, slow movement, muscle stiffness, balance problems, and shuffling gait. One of the biggest problems, symptoms usually appear only after a large percentage of dopamine-producing neurons have already been lost. So by the time patients are diagnosed, the disease has already done serious damage.
And that brings us to our protein target, alpha-synuclein. Alpha-synuclein is an abundant protein in the human brain that regulates neurotransmitter release at nerve terminals. In Parkinson's disease, this protein misfolds and clumps together, forming sticky and toxic masses known as Lewy bodies.
These clumps progressively damage nerve cells and cause them to die, leading to the common known movement and cognitive issues of the disease. For our positive control, we use
Buntanetap, an experimental oral medication created by Annovis Bio, which targets alpha-synuclein. Buntanetap goes directly to the source, directly targets one of the causes of neurodegeneration. By directly targeting alpha-synuclein, Buntanetap aims to protect neurons and potentially slow disease progression.
We then began to look for alternatives, searching for a more effective and safe treatment. We compared Buntanetap to 10 possible alpha-synuclein targeting compounds.
Synuclein D, Anli-138, SK129, squalene,
Quercetin, paralochylene-quinone, CLR01, CPD2, bicholine, and curcumin. These were chosen because they had previously been studied for slowing neurodegeneration caused by Parkinson's disease. We ran them through toxicity screenings and molecular docking in order to predict binding and determine any possible safety concerns.
But enough about Butanap. What's our solution? Parkinson 01, developed by Bayer Essentials. Parkinson 01 is our proposed alpha-synuclein inhibitor with this active ingredient and enruselment. While running it through screenings for toxicity and docking, we found surprising results.
When we ran our screening, the results were surprisingly promising. Buntanetap, our positive control, had a toxicity class of 1, which was the most concerning category in our toxicity model. Parkinson 01 had a toxicity class of 4, suggesting a less severe predicted toxicity profile. Then came docking. For alpha-synuclein, position 2, Buntanetap scored negative 7.7, while Parkinson 01 scored negative 8.6. For position 6, Buntanetap scored negative 6.4, while Parkinson 01 scored negative 6.5. And in docking, more negative scores suggest stronger predicted binding. So Parkinson 01 showed stronger predicted binding in both alpha-synuclein conformations, while also showing a less severe predicted toxicity class. That gives us a clear next step.
Parkinson 01 deserves further preclinical testing. Not because docking proves it works, but because the early data makes it worth investigating. Based on our computational results, Parkinson's 01 was selected as our lead candidate out of the 10 alternatives. Its strengths are stronger predicting docking score and less concerning predicted toxicity class compared with Butanap, but it still has its limitations.
These results are computational predictions, not proof of safety or effectiveness.
Future testing would need to include experimental binding assays, cell-based Parkinson's models, full ADMET testing, and eventually in vivo studies.
Parkinson's is rising. Current treatments mostly manage symptoms. We want to go after the disease closer to its source. Parkinson 01 is our proposed alpha-synuclein inhibitor, designed to target protein clumps linked to neuron death. With your investment, we can move from computer models to real testing. Invest in Bayer Essentials. Help us take Parkinson 01 from prediction to protection, because wellness shouldn't be unbearable.